So first of all, like happy Gandhi Jayanti and Lal Bahadur Shastri Jayanti. Okay. So ఇది గాంధీ జయంతి స్పెషల్ ఎపిసోడ్ కి ఈరోజు మరి 5 hours
Okay.
తీసుకోను కానీ అట్లీస్ట్ లైక్ 3 hours పట్టేలా ఉంది.
Okay.
Yeah. Uh,
Okay. మరి.
so before actually jumping into like today's session, like do you have any questions in previous session? Like,
Hmm. No, you are going to do research on a couple of things and come back.
yeah, I did that research, so I have like few slides also around that area.
Okay. Okay.
Okay. So apart from that, like I just assume that so you're actually practicing because like without practice, like once we even though we listen to these sessions, like they'll not help us much. Self practice is very much important. So I
Yeah.
hope like you'll spend good amount of time because like SQL is very important. Like so even though if you go for like any other technologies like Spark or any big data technologies, so without SQL like you'll face so much of difficulty. So there is a person called as like Eric Weber. So he's from LinkedIn. So he's a data scientist in Yelp. Okay. So I'll also show. So he actually like posts some many important things like so related to SQL. So he's the one. So he works at L. So if we follow him, like so, he posts many interesting things related to SQL in big data. Okay, so he also asks us like very interesting questions. So hope like you guys also follow him, like Eric Weber. So he's the guy. And also I assume like so you're following like Brent Ozer and then a few other people like whom I mentioned in the last session. Okay,
How many?
so
How many have done that? Let's. Um, so do a post on click and
yeah.
see how many do the thumbs.
So he's a funny guy, like his sessions and then his posts are really good. Okay. So he's the guy, Brent Ozer. You can just follow him on Twitter. Okay. So let's get into some of these things. Uh, yeah, so last week, like there are a few items which we didn't actually discuss. So one of those items is related to LOB pace for when we have like more than 8,000 bytes for a varchar, right? So if you remember, like previously, like when we tried to have a varchar of max column, and then when we tried to insert like 10,000 characters, when we tried to insert like 10,000 characters, like at that time, like we didn't actually see LOB pace, right? So hope you remember the concept. Like so, whenever like we use varchar of max, hello, yeah, am I audible?
Let's go.
Yes, sir.
Okay, okay. Yeah. Okay, yeah. So last week, like we had an we had a discussion about like what columns actually go into LOB pages and what other columns like we can store only max of 8,000 characters. Like all the basic data types like varchar of a number and then char. These items like we can actually store only 8,000 bytes, whereas like varchar of max we can store more than 8,000 bytes. 8,000 bytes. So at the time, like we saw a small demo. So I tried to create a table with only one column, varchar of max, and then I tried to insert like 10,000 bytes. Okay. And when we saw like the pace data, so we are seeing only one pace, right? Hope you remember this particular scenario. So we saw only one page. So ideally, we are supposed to see like one in-row database and then one LOB pages and then LOB pages, right? But unfortunately, at the time, like when I'm demoing, like I'm not able to show you like so LOB page, and I'll just go through the reason why we didn't actually see those LOB pages. So let's just execute this particular. So on that day, what we did is like the mistake. So just we tried to execute this SQL replicate, so which is actually used to replicate a string or character these many number of times. And when we tried to paste it on a new page, so what we saw is like, so we actually saw the ending strings as X. So, and we didn't actually count like how many strings were actually present, right? So that's a mistake we did. What we'll do is like, so let's try to append ABC at the end. So let me copy this. So you can also try meanwhile. Yeah. So now you can see like the at the end, like we are not able to see ABC. So we are not seeing this ABBC. So something is happening. So let me see like how many characters I'm able to store actually, how many characters I'm actually getting. Uh, so quick count like, okay. So you can see like I'm getting only 8,000 characters. That's the reason why like we are seeing only one in-row pace, but not LOB pace. So even though like we are actually using this replicate of X and then 10,000, so this X is getting replicated only for 8,000 items. Okay, so that is because so this accepts like this is the string that it is a string type like so there is an URL like I'll also show you like as per Microsoft. So this is actually restricted to 8,000 characters replicate unless we cast it explicitly. So I have this URL. Okay, so I can just show you what's happening. Yeah, so if we go to this particular replicate function documentation, so you can see here like if the string expression input is of type varchar of max or unvarchar of max, replicate truncates the return value at 8,000 bytes. So it is actually truncating to 8,000 bytes. So to return values greater than 8,000 bytes, a string expression must be explicitly cast to the appropriate large value data types. So we need to actually typecast it to a large data type. So unless we do that, we'll not get like more than 8,000 bytes. Okay. So you can just see that. So various examples. So I'll just execute. So initially, like I'm trying to replicate A 4,000 times, B 8,000 times, and C 11,000 times. Let me execute this. So you can see like, so B length of B string is like 8,000, whereas like C, it replicated only for 8,000 times. Okay. So in order to solve that problem, what we need to do is like, so we need to explicitly convert it to varchar of max. Okay. So unless we do that, so we'll not be able to get more than 8,000 bytes. So now for this particular string, I got like more than 8,000 bytes. Okay. So now let me try to drop this page and then recreate so that like we can see LOB pages. Okay. So I just created that, right? Let me replicate this explicitly. So now let's see the page structure. So now you can see, just ignore these pages 10. So they are IAM pages and more specific to SQL Server internals. So these are the actual databases. So this is one database and these are the two databases. Okay. So you can see like we have one in-row database and then two LOB pages. So can someone please give me the reason like why we got like two LOB pages here? And what's the difference between text data type and varchar here, like varchar of max here? Anyone? Just you can guess it.
Yeah,
So,
we're not able to hear you.
hello.
Yeah, yeah. You're audible, Pawan.
Okay, okay. So, anyone guessing? Yeah, Nirza, tell me.
I'll need to get you a new laptop, maybe.
So, we saw
You
like
might.
a varchar of something like up to 8,000, and then varchar of max, and also text data type. So can someone just brief me like what's the difference between each of these?
Text um, um, has all of the data in LOB and varchar max. Nirja, we're not able to hear you.
Yeah, so I'm getting some noise from her side.
Yeah,
I
yeah,
might be.
yeah. Her
Yeah.
mic is not right. Need to
Okay. Okay.
replace her laptop. Okay.
Yeah. So just try. Okay. So what's the difference between these three data types? Just a small question.
Okay, varchar. Yeah, it's since nobody is answering. It's
Yeah.
like
Yeah.
I'm the only one who's following. Gayatri wants to answer. Okay.
Okay.
Yeah, so varchar it only accepts the 8,000
This one. Okay.
characters. So
Yeah.
varchar of max can accept more than 8,000 characters,
Hmm.
and text also can accept more than 8,000. But the difference between varchar of max and text is like in text, data will not be saved in row data. It
Hmm.
will be saved in LOB pages.
Hmm.
In row page it will store only the LOB links and something, no, not the data. So
Hmm.
in varchar, in row data page also we'll see the values that are inserted in that.
Okay, that's perfect. Like, okay, so but in this case, so you can see like when I'm trying to insert like 11,000 characters, so I have like one in-row database and then two LOB pages. So any guess like what might have happened here?
I think intro data is storing the indices of LOB data pages.
Yeah, exactly. So in this case, so varchar of max is behaving exactly like text data type. Okay, so you can see like so in row database. So previously, like when we just had like varchar of max and then tried to insert like 4,000 bytes, at that time like in row data has like data like all those 4,000 bytes we are able to find them in row data. Okay, but now let's see what content do we have in row databases. Okay, so this is my in-row database, right? So you can simply see, so I don't see any data here, like, okay, so these are like memory dumps, so which is actually pointing to another page, okay, which is actually pointing to LOB pages. Uh, so let's see one of these pages. Okay. See, we can see all this data. Okay, so this is one LOB page. Let's see like another LOB page. This is the other LOB page, right? So even here, like we have some data. Okay, all C's. Okay. So in this case, like varchar of max is exactly behaving just like text data type. So even in this case, like varchar of max, so we are actually storing pointers to LOB pages in row database, and text data type also does the same thing. Like it actually stores pointer to in LOB databases. So then what's the difference between these varchar of max and text? So there is a minute difference. So in text, even though like if you try to insert like 2,000 characters or 1,000 characters, still the data goes into LOB databases. But that's not the case with varchar of max. So if the count is less than 8,000, so in-row databases will only have the data. There is no point of having like these LOB databases. Okay, so that's the difference between varchar of max and text, and you're able to see these LOB pages, right? How the data is actually distributed among these LOB pages. So any questions on this? So any questions?
I think it is
Clear? No, okay.
clear.
No, okay. So let me go through my next slides. I'll share these things. Meanwhile, like if anyone wants to try, so they can simply try. I'll post them over here. Okay, so another question, I think like Shrikant asked this question. So where exactly do we store like, the foreign key related information? And also, yeah. So before actually going into the topic, like where exactly do we store this foreign key relationships? So does anyone know, like, let's say like I have table A and then table B. So I want to have like foreign key relationships. So in that case, like is primary key mandatory on one of those tables? So I'll just
I don't think mandatory. Yes,
okay.
mandatory.
So just post your opinion here, like thumbs up and thumbs down. Yeah, just post your. Okay, so I'm seeing 3-3, and there are like 11 members or 13 members participating. So I am assuming that people are not voting for both of them. Okay. Okay. So I see like majority they're saying
Yeah,
like
I said it is primary key is mandatory for foreign key.
okay, primary key is mandatory for a foreign key relationship. So any guess like why primary key is mandatory?
Is there a primary key or a unique constraint?
So,
Uh,
Pawan,
yeah.
my assumption is like uniqueness constraint is mandatory, where that's where I voted for downward.
Okay.
So,
Okay, so let's see. So there is actually a thing like so primary key or like an index is actually mandatory. So let's see a small sample. Okay, and I'll just give you an example of why it is mandatory. So meanwhile, you guys can also try this. Okay, so let me drop those tables. Okay. So I'm just creating like two different tables. Like one is department table and then employee table. So department ID, department name, and then employee ID, first name, last name, department ID. So I'll be creating like initially like I'll not try to have any primary key or any of those indexes. And then here like I'll just create like a table. Okay. So this is my department table. And then I'm just creating like employee table. Okay, so I got an error. So there are no primary key or candidate keys in the reference table department which matches the referencing column list in the foreign key. Okay, could not create constraint or index. Okay, so it is actually complaining that so I'm not able to create a table of, I mean foreign key relationship with the department ID because I don't have like primary key or candidate keys. Okay, now let me try to create a small index on top of it like uh, okay, so I created a cluster index. Now let's see like if this actually works, but still it is not actually working. Let me drop these tables and then create a primary key. Okay, so now let me try to create an employee table. Okay, so now it is successful. So from this, like what I understood is like, so in order to create a foreign key relationship, so we need to either have like a primary key or like candidate key. So candidate key is nothing but like a combination of two or more like columns as a primary key. Okay, so that is actually mandatory. To some extent, this made sense for me. So any guess like why primary key might be mandatory here? So even I did a guesswork. So and to some extent, like I support my statement. So I'll also see like so any other guesses like apart from
Uh,
me.
Primary key is used for avoiding duplicates, where foreign keys can be like we can have few duplicates in foreign key if we go in deeper.
Yeah. So that might be one reason. So another reason why I thought like so having primary key is a good thing. So let me actually show you. So I created these two tables, right? Department table and then employee table. Okay. So they already exist. So let me insert a record into department. Okay. So let me execute this particular statement.
Are you using your new laptop?
Yes, Kiran. So this is very good. Like,
Okay.
yeah. Okay. So let me insert this particular statement again. Okay. So I inserted a record into department table. So I'm just trying to insert a record into employee table. Okay. So any guess like so what might have happened behind the scenes? Like how does the constraint actually check actually made or something like because like foreign key relationship is nothing but like so whenever we have two tables, so when we are referencing to the other table, so department ID should exist in the other table, right? So when I'm inserting a record into employee, so what might be the execution plan? So how so any assumption on how things actually went behind the scene? Okay, so I'll just show you. So the execution plan. So before actually going, so something might have happened. So here is the case. So when we insert a record into employee table, so it needs to check like whether this particular department ID one, it exists in the database or not in the table, right? So if it doesn't exist, so obviously we need to throw some kind of error. So insert statement conflicted with the foreign key constraint. The conflict occurred in the database department column, department ID. So because like two doesn't exist on department table, so we are getting an error. So that's the reason why like I'm inserting one. Okay, so when we are actually inserting a record with one, so how this is actually working? So before actually inserting a record, so SQL server might actually take this particular value, department ID value, and it is actually supposed to check like department table consists of that value or not, right? So that should happen in order to preserve the constraint, foreign key constraint. So let's see the execution plan, whether that is happening or not. Okay, so this is the execution plan. We are actually doing a table insert, inserting into a table. So here we can see like we are actually doing a cluster index seek on department table. Okay, so here you can see. So what we are actually doing, so SQL Server is actually before actually inserting into this particular table, so it is also doing a seek. So it is also querying department table, and then finally it is asserting. Okay, so assert is nothing but like whether the condition exists or not, either it is true or false. So in case if it is true, so only if the record exists, so then only it is actually going to do an insert. Okay, so in this case, let's say we don't have any primary key or we don't have any index on that particular column. How costly is this operation, like insert operation? Let's say like we are actually, we saw like last time in the post table, we have almost like 3 lakh or 30 lakh records, right? Just in the post table itself, like Stack Overflow 10 GB post table. So in that case, if we want to do a scan every time, so if we don't have a clustered index C, if we don't have a clustered index on department table, or might be just take the example of post table. So every time we are supposed to do a scan. So scan is nothing but like traversing the entire data, entire table data, right? So for just one insert, if we are traversing the entire table data, so how costly the insert operation would be? it would be very costly, right? So that's the reason why, why one of the reasons what I am thinking is like, so they've enforced like primary key should be present. Like that's the another reason why I tried to create like a clustered index before actually creating the primary key index is like, so if clustered index is present, might be I thought like they'll be using the clustered index. So, but that didn't actually happen. Like, so as we know, like when we create a primary key, it obviously it will create an clustered index. Okay. So any questions?
Yeah, Pawan, one question.
Yeah, funny.
Okay. So we are having that primary key on department ID, right? Say suppose our foreign key refers to another column in department, and we are not having a key on that. Then how would this come into picture? Like how would this be helpful? For
Um,
that, it need to search the whole table again. Oh,
yeah, so that's the reason why like they enforce like I think like you're not aware of. I mean, so you're present at 10 minutes back or not? But we saw right. So when we tried to create like department table and then employee table, so without having the primary key, we are not able to create the table.
yeah, but department ID is still a primary key.
Yeah,
We'll have another column.
you wanted to have something like this
Yeah,
department
so
name.
if it refers the department
No,
name, then
it doesn't actually work. So it is actually tied to primary key.
okay. So the key which we are the column which we are referring to is
Yeah, so
should
you can see
must be
like
a
the
key.
message that matches the referencing column list in the foreign key. So this particular column key is not actually a primary key or candidate key.
Okay. Okay.
Okay.
Yeah.
So I was actually thinking like that might be one of the reason why they had enforced this primary key constraint on for foreign keys. So without actually having like a primary key, so people they had to explicitly create the clustered index, and before actually creating the clustered index, they might face this trouble, right? Like the index scan and everything. So hope you got the problem statement and why they might have like primary key constraint. So that was one of my assumptions. Like, so what the South said, like that is one thing, and this can be like another reason.
Okay. Yeah, got it.
Okay. Okay.
Pawan, if this is Jalaji, if
Yeah.
we have the foreign key as a null,
Hmm.
how it will, is it going to check in department table or not?
No.
So no, this will
Right?
not actually check. So I'll just execute that. So nulls for nulls, like it doesn't actually
No,
check.
how the execution plan?
Okay, so even for that, like I think it goes into the C code. Let's check that.
Mm,
Okay, so this time like it is
won't
not even doing in seek.
right.
So it is directly inserting into table insert. So SQL Server is more smarter than us.
Okay.
Yeah. See, so how beautiful it is, right? So when we actually have the value, it is doing a seek. So when we are not actually passing the value, so it knows like it is aware like so it is waste of time to scan like department table, like seek department table. So we are saving like few logical rates, right?
Yeah.
Yeah. So okay, so that was one thing like Srikanth that answers like Srikanth's question. So I'll also show you like where exactly did we have these tables. Okay, foreign key information is stored. So there are like few DMVs. Okay, so one of the main DMV is like sys.objects. So sys.objects has all the information. So I'm just checking for like the foreign keys. So in this table, like I have only one foreign key. So which is so its object ID is like this is the object ID. Okay. So and also we have something called as sys foreign keys. Okay. So in this sys foreign keys, so you can see like sys foreign keys, like you can see like foreign key ID and then reference key ID. So what these foreign key and reference key IDs are? let's see. So they're like object IDs. Okay. In sys objects. So one is like 20999048. So that is like employee table ID. Okay. And then the other one is like a department table. Okay. So this is just overview like where exactly we store this foreign key related information. So they don't actually sit in the databases. So databases are strictly for storing the data. So if we want to see the code base for this sys foreign keys, sp underscore help text, you can do. So you can also see the code, sys foreign key columns. So there is another view, sys foreign key columns, and you can just dig deep into some of these DMVs. Okay. So I think like hope I answered these questions. So there is another question. Yeah. So why text data column is not accepting equal to? So why we are not able to perform like equal to operation or text data type? I didn't actually find a reason on why they're actually preventing that. So the solid reason from Microsoft. Okay. So they just mentioned like, so text data type, like we cannot have like equal to operator. And one good thing is like it is ways to research, do much of the research on this text data columns, because like text data column and then end text, they are all deprecated columns and they'll be removed in future releases. Okay. Okay. So last time, like we saw some of these things, like so. Can someone recap like what are all the different types of indexes, scans, seeks that are available? Apart from me recapping. So maybe what I'll try to do is like, so I'll pick one from the list. Okay. So I see almost like 25 people, right? So I'm assuming like all 25 people attended the session, like previous session, or they went through the recordings. So what I'll try to do is like, so I'll pick some random people. Okay. And then they can just answer me. So Neerja is my favorite student. Like, so I'm amazed with her skills. So let's ask like Neerja. So what these things are like? So I think like Neerja has some problem.
She's speaking in code, so
Okay.
in
Yeah.
binary code.
So my next favorite is like Durga Rao. So let's pick Durga Rao.
Neerja,
Neerja. So
you can type your answer if you want.
yeah. So meanwhile, like Durga Rao, so you can just answer like, so what are all the different types of seeks and scans we saw last time? So anyone else, like I'm fine. So instead of me picking like, so if someone wants to answer, no issues. Like, but I want to answer from someone in the team. Like,
It's like seek and scan
okay.
and cluster seek
Okay.
and non-cluster scan.
Okay. Okay.
And
Yeah, so we saw like few types, like one is a table scan. So whenever like we don't have any indexes on the table, so then in that case, like we'll go for a table scan. So that is also called as like heap scan. So whenever like you come across this state word like heap, so heap is nothing but like a table in SQL Server which doesn't have like any indexes present on it. So the table doesn't have like clustered index or non-clustered index. So the table doesn't have any kind of indexes. That is called as heap. So on heap, so we'll usually do table scan. So that is table scan is one. And then we have like clustered index seek, non-clustered index seek, clustered index scan, and then non-clustered index scan. Okay, so the difference between clustered index and non-clustered index. So in clustered index, so the data page, the leaf pages, so they'll have all the data, whereas non-clustered index, the leaf pages contain pointers to clustered index again. Okay, in case like clustered, there is no uh, clustered index on a table, but we have only non-clustered index. In that case, like clustered index leaf nodes will point to table heap. Hope this is clear. Okay. So now let's get back into the regular stuff. Okay. So let's start from users. Okay. So select start from users top. So in this case, can someone tell me like what will be the plan, like execution plan? So does it do a seek or scan, or what do you think like is happening in what, any guess like what happens?
Seek.
Seek. Okay. So is it Sita? Okay. So in this case, seek or scan. The statement is like select top 10 star from users. So you can just quickly vote. So this is for seek, and second one is for scan. Okay. So Naik and Murli, so you opted for like scans, right? So can you just justify your statement, like why you thought like it goes for scan?
In last session, as we saw, as we had a star, it has to scan through all the records in the table.
Okay. So do you think like if I have a where condition, so even in that case, like it goes to scan? So where something like ID equal to 10?
Mm,
So in this case, it will be scan, right? Seek, right? Okay.
yes, yes.
Okay. So as majority of them, like they went for seek. So I see like almost 25 people and 25, and then only 30 notes I got. Okay, but still that is good. So I see like majority they opted for seek, and only two they went for scan, and I am assuming like Murli and Naik are those. Okay. Even Kiran went for scan. Okay. Yeah. So when it goes for a scan, so do you think like this is a costly operation?
Mm,
So
No, since it knows that it is only the top 10
yeah.
or X number of records,
Okay.
proportionate of the total, then it
Okay.
will go for the scan instead of the
Okay.
seek.
So it actually goes for scan instead of seek, right? So when
Yes.
we say like scan, so as per last week's discussion, so we saw like seek is nothing but like it traverses the B tree from top to bottom, right? Whereas like scan, it actually traverses the leaf node pages, the entire table. So that's what like we thought, right? Last week, scan is nothing but like entire table scan.
Mhm.
So do you agree with that?
yeah.
Okay.
So in even there, I think it goes to only specific set depending on how many number of records, right?
Yeah, exactly. So that's what happens behind the scene. So even though like this, it goes for a scan. So let me show you the execution plan. Okay. So this is a huge table. Like, so we have almost like 30,000 plus records. And then, so let's see the execution plan. Okay. So it does like scan. So Scan is nothing but like how many. So when we are doing like scan, how many records do we expect? So we expect all the records to be read, right? So but here that is not happening. So you can see like number of rows read 10. Okay, so estimated number of rows per execution are 10. Okay, did you see that? So again, like SQL Server is very smart. What it is actually trying to do is like, so it is actually starting the scan. Scan is nothing but like, so as I mentioned, so let's say like, uh, so these are my leaf level pages. Okay. So these are my intermediate pages. This is my top level page. Okay, so these are leaf level pages. Okay, so whenever like seek happens, so what seek does is like, so it goes to the top level page, and then from there it goes to the intermediate level pages, and then finally it goes into the leaf level page. So whereas scan, what it does is like, so it starts from one end of the particular pages. Okay, so it starts from this end or either this end. Okay, and then it traverses each and every record, one record after another record. Okay, so you can see like if you see like the data pages for the page structure for the leaf level pages, so you can see like we have previous and also next page IDs. Okay, for traversing, like those items will be used. So in this case, what is happening is SQL Server, like it started scanning. Okay, so it started scanning from one end, and then it went up to 10 pages, 10 records, and then it stopped over there. So that is the reason why, like, not so. This is the reason, like, not all the times scans are bad, and not all the times seeks are good. Okay. So this is just an example where like scan is very good. So we are reading only 10 records in this case. Hardly like we are reading only one page. Okay. So any questions?
No.
No. Okay. So let me try to do another thing. No. So I'll just query based on the reputations. Okay. So reputation equal to 1. Okay. So what do you think? Like, so what happens? Like, so I'll also show you the indexes that I have on this particular thing. So I have like two indexes. So one is like primary key index, like I index on ID column, which is a clustered index, and I have an non-clustered index on display name. Okay. So let's actually go with the display name part thing only. So when I execute this, so what do you think? So does it actually do a query, or I mean, so does it actually do a scan or seek?
This will go for seek.
Okay, so let's see.
See the execution.
Okay. Can you just answer me like on what basis does it go for seek?
With the key display name.
Okay. So I have like a non-clustered index on display name. Okay. So I have non-clustered index on display name. So I think like Murli is answering, saying like this actually goes for seek based on this index. This will actually use this index, right, Murli?
Yeah.
Okay. So any other options? Scan or seek? So Murli, like another question for you, like how does like SQL Server actually like decide like whether I should go for seek or scan? even though we have an index?
Mm,
So last week, like we saw another important topic.
Depending on the key, not the key.
Hmm. So anyone else, like not only Murli?
No, I don't know.
Yeah, anyone else can answer.
Based on the statistics, it is checking the threshold and deciding upon scan or seek.
Exactly. So this will actually make use of statistics. So let's see like what the statistics looks like for this particular thing. Okay. Uh, DBCC. And this is my index name. Okay, so let's see statistics. Okay, so these are the statistics, and statistics is nothing but like when we create an index, so these statistics they get created. Okay, so what SQL Server actually does is like, so basically let's say I have like 5 lakh records. Okay, so we can take like almost like 201 steps, I believe. Like I'll just also, you can just research on the exact number of steps that can be created. Okay, so what SQL Server does is like, so it actually takes a few sample records. Okay, so from one, so let's say like from Aaron to Adam. Okay, so how many matching rows are there for Aaron? Okay, so which is nothing but like equal to row. How many records are present between Aaron to Adam? Okay, so these are all sorted. Okay, how many records are present between these two items? So basically like it might be like, so 11178. Okay, so these many records there might be, so you can just see. So that way, like let's see where Pawan actually goes. IJKLMNOPPAVAN. Yeah, so it goes on somewhere here to here. Okay, all right. So as the number count is very less when compared to the actual page count, I'm just going for seek here. Let's see if that is the case or not. Okay. No, okay. Yes, it is going for seek. So it is going for a seek and then it is going for key lookup.
Okay.
Got it. Okay. So why key lookup? Key lookup? Anyone?
So as it is a non-cluster index, right? Display name. So still it is pointing to index. At leaf level, it is pointing to index.
Yeah, exactly.
Clustered.
So leaf label doesn't actually contain the data. So it is actually pointing. So it has like ID column. So clustered index ID column. Okay. So that that way, like it is actually pointing to clustered index. Okay. So that is perfect. Like, so this is actually going for seek. So let me try to do small thing. So what columns do we have? Like, okay, ID, comma, is, comma, display name, comma, location. Okay. So these are the items which, so in this case, what do you think? Like, so which operation does it kick in?
Seek power.
This time seek.
Yes.
So you just see the query.
As you earlier you defined, right, where display name is equals to Pawan. So at that time you showed DBCC statistics. There was a little records in between them, right?
Okay,
So that's
so
why I assumed like it might go
go
to.
for seek. Okay, so let me execute this DBCC statistics again. So where exactly this Pawan ABCDFGHIJKLMNOP? Yeah, Puja Kadu. Yeah, so it goes somewhere here. Okay. So out of these 119 records, like 200 records, so there are almost like 131 items just before this. So here I'm doing less than Pawan. Okay, not equal to operator. Okay, so this time my assumption is it should go for scan. Scan, yes. So which scan? Clustered index scan. It is not clustered index, non-clustered index scan. It is clustered index scan. So anyone can answer like why it went for like clustered index scan, but not non-clustered index scan.
Is the primary key itself the clustered index ID column?
Yeah, so primary key itself is clustered index, but here in this case, I have a index on display name, right? So when I have a display, so clustered index is built on top of ID column, right?
Yes.
So in this case, I am just varying it on display name, and I have an index, non-clustered index on display name. So why it is making use of clustered index scan instead of non-clustered index scan? Any wild guess? Like
Data will be present at the leaf node.
okay. Priti, inkoncham elaborate.
Clustered index scan అయితే ఇక్కడ statement ID, age, display name, location we are selecting. So there the data will be present at the leaf node for clustered index.
So what happens like if we go for non-clustered index scan?
Then we also need to have a key lookup. So in order to avoid the
Exactly. So in order to avoid like key lookup, so anyhow, like I need to scan the table. So if I go for like non-clustered index scan, I don't actually exactly know how many rows are there. So yeah, I know. So SQL Server actually know using statistics, it makes use of statistics. Okay. So using statistics, okay, it thinks like, okay, more than like 70% of records fall under this query. Okay. So when I need to so anyhow, like I need to get the data, 70% of records data like ID, display name, location, ID is location from clustered index space. Okay. So what if I go for like non-clustered index scan? So I need to scan non-clustered index, and then I need for each and every record like 70% of those records. So I need to do again seek, key lookup. Key lookup is nothing but like clustered index seek kind of thing. Okay. So almost like let's say like out of 100 records, so there are 70 matches. For 70 matches, so for 70 matches you need to do 4 pages. So for each seek, like key lookup will approximately cost like root level page, one intermediate level page, and then the equivalent leaf level page. So it is like for one ID, so I'll be traversing like 3 different pages. So which is costly operation, right? So instead of that, so anyhow, like I have data that is present in clustered index, right? So in the leaf level pages. So if I can scan that, so that will be optimal. So that is what SQL Server are actually thinking. And then it is actually doing a scan on clustered index, not on non-clustered index. Okay. So any questions?
No.
Okay. So
How
I'll do
can we check for same query for greater column?
for greater? Okay.
Yes.
Yeah. So guess like I mean, let's guess like what happens. So here it is like greater than pound, right? So it falls somewhere here like LMNOP. So out of like, so there are approximately like 70 pages, 70 records, 70 more items, right? So what do you think? Like, so what happens? Scan or seek?
Scan.
Scan. Okay. So even I'm going for scan. So it is actually going for a scan. So that is because like last time I said, right? So only for 10% of the data. So if clustered in, if from the statistics, like if the engine was able to find like, okay, so there are less than 20% of records. So then, okay, so it is optimal to do an non-clustered index seek or scan. Okay, so in other cases it will go for clustered index scan. So this 20%, and again, like this is a big debating thing, like in SQL Server world. Like some people they say like it is 20%, some people say 10%, but there is no specific number guaranteed. Okay, so is it clear or any questions till now?
Once more. Okay, instead of all those four, if we have only display name for select, then it should go for seek.
So if it is display name and location,
only display name.
only display name, not
Yeah.
even ID.
No.
Okay, so what do you think?
As
Like,
this
so
is
it
all.
goes for like clustered index or I'm non-clustered index seek or scan, or what do you think?
So I am thinking it will go for non-clustered index seek.
Non-clustered index seek. Okay, so how many of you are with funny?
So I'm with funny Anna. I am.
Okay, so let's see what happens here. So it went for index seek, non-clustered index seek. Okay. So funny is good. So what if I have like ID funny?
Okay, in case of ID, it again needs that key lookup. So
So
it is still a
it again
seek
needs
and
key lookup.
yeah.
Okay, so how many of you are with funny? So you're saying like it goes for non-clustered index scan. I mean
No,
clustered index
non-clustered
scan.
seek and yeah. No, I think non-clustered seek and key lookup.
Non-clustered index seek, comma, key lookup. Okay. So for this query, options polls. Non-clustered index seek, uh, non-clustered index scan. Okay. So first one, second. This is first, and this is second. So you can start what. And here is my query. So ID and then display name. So majority are going with clustered index scan. So we have 25 people and I'm seeing only 11 nodes. Fast. So I think like all of you, so you're actually done with voting. Okay. So 4 people like they went for non-clustered index scan, and then the remaining they went for like seek, clustered index scan. So I'm just doing ID and then display name. Okay. Already execution plan చూపించాను. Okay, so it is actually going for non-clustered index seek. So any reason like why it is going for non-clustered index seek?
Because that display name is already present in that non-clustered index. So
Okay. Can someone like, so can you guys like see what exactly is happening? Like, so what the leaf level page looks like for non-clustered index? So it is like a DBCC IND, DBCC IND, and then table name is stack overflow 2010, and then index name. So is someone looking like what? index ID is 4. So what is the syntax for DBCCIND? Much better. Stack or 2010, and then the table name, right? So table name. So we have this query. So you can also check this query. Okay. Okay, so this is my non-clustered index. And these are my pages, right? So this is my root level page, and then this is my index level page, DBCC, CCIND, DBCC pages. So let's say this is my page. So this is my root level page, right? So are you looking at like DBCC pages? Okay, so this is my page. Okay. So here you can see like you are seeing like display name. Along with the display name, you're also seeing ID column, right? Okay. So when I already have like a display name and ID column which is present in the leaf level page, so it is ways to go for like clustered index scan, right?
Yeah.
Or like if you remove the display name from select query,
Okay. Only
then
display name?
yeah, only display name.
Okay.
No,
So
we should remove yeah, display name. Yes.
yeah. So in this case, like what do you think? Like so what actually kicks in? Clustered index seek, scan, non-clustered index seek, scan.
Scan.
Okay. Non-clustered index scan or seek?
Non-clustered index scan is what I'm thinking. Let's check.
Okay, let's see. Okay, so it is actually doing seek. So the decision, it actually depends upon the number of columns it is actually touching. Like so in this case, like it thought like okay, so it is better. So as it is like non-clustered index, so we'll not have those many pages, like right. So it is okay to actually scan like all these pages. So then it actually went for non-clustered index seek.
Sleep went for seek.
Yeah, it went for non-clustered index seek. So non-clustered index seek is what we should actually focus on. So
Yeah, means looking into the query, do we have any easy methods like where we can guess like this is going to have like it's going to scan or else like it's going to seek something like that?
yeah, so first thing when we are actually doing, so let's say like we have two items, right? We have like clustered index and then a non-clustered index. Okay, so non-clustered index and clustered index. So I have clustered index on ID, and then this is on display name. Okay, so this is what is actually present, right? So whenever like we have star, okay, okay, so in this case, and we have like something like id equal to 10 or something like that. Okay, so based on the statistics, okay, based on the number of items it is actually going to touch, so it actually goes for, so in this case like my where condition is on id column, which is nothing but like my cluster index column, right?
It will go for seek.
So
Yes.
this will actually go for seek.
Seek.
Okay,
Yes.
so this will go for seek. So whenever like we are actually touching lot of data, okay, so let's say, so we are actually touching more than good amount of records. Okay, so let's say like 1001 or something like that. Okay, so in this case, so statistics come into picture. Okay, so it is still like seek, right? So why it is still seek? So let's see
On
statistics.
ID, like actually, what was my thought is like ID is less than.
Mhm.
So if it is ID clustered, if you are giving any conditions on clustered and non-clustered, if you are involving any other than this clustered and non-clustered indexes, then we are going for scan in few scenarios, like not in all the cases, like in few
Yeah.
cases we are doing.
So in this case, yeah. So in this case, like it went for seek, right? So
Seek.
the decision how it
Because
is actually made. So it is actually made based on the statistics. So I'm using like 10,002, right? 10,002 means 1, 2, 3, 4, 5 digits. 1, 2, 3, 4, 5. So it isn't top 5 levels only.
yeah.
This is statistics. So which is obviously out of like 24 pages, like just 5 pages. So which is not even like 20% or something like that, right? So let me actually modify this query so that like I'll just do it less than on this side, this value. ID less than this value. Okay, so in this case, like what do you think so happens?
If it's 20%, then it should be going for
So it
still.
should go for scan. So you go for seek.
Yes.
Okay, yeah. So let's see like what's happening and I'll then explain. Okay, so this case like it still went for seek. Okay,
Yes.
so let's take another thing.
Scan.
It still goes for seek.
Scan.
Okay, so last time, like if you remember, the first thing what we saw is like, okay, so this is almost like I'll do another query. Select top one star from users where order by id, order by order by id descending. Okay, so this is my max value, right? Okay, so out of like let's say like count of star, I'll do. So out of these many records, I'm just querying less than one, only one record I'm skipping less than this value, right? So I'm just actually querying for these many records. Okay, so it still went for seek, right? So it still went for seek. Let's see like statistics, set statistics I go on. Okay.
Okay, it might be because of that ID, where ID is we are having this clustered.
Yeah. So I'll just show you like how many pages did we read. So we read almost like for this query. So we read almost like 7405 pages, right? So let me do another query. Okay, so this is my query. So let me try to execute this query. and see the execution plan. So in this case, like how many records I got? I got only these many records. Okay. So what do you think the execution plan will be?
Scan.
Yeah. So it will be scan. Okay. So it is doing a scan. Let's see like how many pages. So do you think like we'll have more number of logical reads or less number of logical reads?
Mm. Mm. More.
Let's see. So in this case, it is almost the same number of logical reads. Okay. So if we can execute this on somewhat bigger table. So this will take some good amount of time. So meanwhile, did you guys see Nisabda movie?
నిశ్శబ్దం కూడా మీకు ఇంకా అవుతుందా పోస్ట్ స్కోర్ రన్ అవుతుందా
ఇంకా అయిపోయిందా?
లేదా అదే నువ్వు పెట్టినప్పుడు నేను
ఆల్మోస్ట్
పెట్టాను
ఎండ్కి వచ్చేసి ఉంటుంది 3 lakh records. Okay. So this is my last ID, right? Last ID value. And let's see like how many page reads did we get? Like this is the number. Okay. So let's try to see one more thing. So this time like okay. So I think like it went for clustered index scan as usual. Okay. So this time like I'll do where ID less than this value. I'm querying almost like same number of pages. Let's see like so what, so here like it went for scan. So here obviously I'm assuming like it will go for seek. So meanwhile, like, am I going fast, or is everyone like able to catch the point? Like, so do you want me to go slow or something like that?
I think even slower people would sleep.
Okay. So this time, like, we got almost like similar number of records. Let's see the pace, and then yeah. So we have like almost this time it go for seek. Yeah, it went for seek. Okay. So it went for seek, and then the same number of logical reads we have in this case. Okay. So what the South are said, like all the time, like when we are actually querying on ID column, it is going for seek irrespective of these spaces. Like so in this case, like even seek or scan doesn't matter, because like we are actually querying the majority of the data, right? Okay. So any questions? Okay, so let's get back to this. So we already saw. So this is actually going for non-clustered index seek. Okay, so even in this case, like it is going for non-clustered index seek, right? But in this case, it is actually going for clustered index scan. Okay, so here, like I'm not able to make use of clustered index scan, right? So in this case, so do we have like any other suggestions for me, like how we can make use of this clustered index? So any idea? Okay, so let me continue. So in this case, so because of these columns, so ID and display name, so it is fine. So I'm able to make use of my index. Okay, for both of these queries. So I'm just effectively using non-clustered index. But for this case, uh, I'm not able to make use of index. So even though what people sometimes they feel is like, so okay, I have a index on this particular column, so the query should be fast, right? So this is where like the columns in the select list they come into picture. Okay, so in here, like because in order to get like few columns from clustered index, what SQL server thought is like, okay, again, instead of making those key lookups, it is better to go for clustered index scan. So to avoid this, what I can do is like I can simply create a index such that create index. So create index always creates non-clustered index. So explicitly we need to specify clustered for creating clustered indexes. So I'll be creating index. Name is idx underscore display underscore location comma is or something like that. Okay, on display. So I'll still create my index on display name. Okay, so it should be like users. So there is something called as include. Okay, so here I can just include whatever columns I want, and then is. Okay, so let me try to execute this query. In this case, so now let's see how many indexes we have. So I have like 3 indexes, right? So which index do you think SQL Server will make use of for this query?
Users underscore display name 1.
Users underscore display name 1.
Yeah.
Okay, so this is another index which we created, like users display name, and then we included A's. This is one index. This is another clustered index, and this is another index. So how many of you will go with the LRG? Like, so just post opinion. Okay. 1, 2, and then 3. So there are like few people who believe that it will actually go with IDX display local A's, 2 with the clustered index, and 5 with display name. Okay, so I'll go for this one. No, not that one. Like I'll go for the first one. IDX display name. Okay. So let's see what happens here. So it is actually going with index seek, IDX, display, and then local A's. Okay. So why is it actually going for this particular index? Okay. So let's see the leaf level, the page structure for this index. Okay. So index ID is 5. Let's execute this. Okay. So we have some of these pages. So this is a root level page. Okay. So this is intermediate level page. So let me check this particular intermediate level page. Okay. So I have only display name and then ID column. So right, I don't have like local or other pages, local information. I mean, location or age related information. Right. This is my intermediate level page. So let's check this particular page. Hoping like this is child level page. Okay. So this is my child level page, and here you can see like I have display name, which is my index key, and then ID, this is my clustered index key. Along with that information, I'm also storing like location and then age related information. You see? So my leaf level pages now have like location information as well as leaf age related information, right? So still like people like who opted for clustered index, it goes for clustered index. Like, do you think like do we have any reason why it should go for a clustered index? So there is no point, right? Because this particular non-clustered index itself has all the data which we are looking for: ID, age, display name, and location, right? So there is no point in going back for non-clustered index. So also like people who voted for the third index, like users underscore display underscore name. So this particular index, like it doesn't have these column level information. So it should again make like key lookup from clustered index in order to get these details, right? Location as well as age related information, right? So even that doesn't make any sense.
Yeah,
So
got
so that's the reason why like it actually goes for IDX display and then ACE, this particular index. So this is how like we can include all the columns, whatever columns we wanted to have in the non-clustered index. Okay. So if that is the case, how many of you think like, let's say now I wanted to add, okay, let me execute one more. Downwards. Okay. So in this case, which execution plan actually kicks in? Hmm? So let's go for poll. So again, like any three you can just make use of. Okay. So you can vote. Am I audible?
Yes.
Yeah.
No, okay. So okay, 4 people they actually voted for this one. So either it might be like clustered index scan or seek, right? Let's see what the execution plan is. So it is clustered index scan. Okay, so it is actually making use of this particular index. So what's the difference? Like the only difference is only column. Okay, so downwards this, but in order to fetch only information related to this particular column, it is again going by. So it is thinking like instead of me scanning like clustered index, non-clustered index, and then doing a key lookup, so it is obviously better to do a clustered index scan. So okay, so any questions still now, or is it confusing?
No questions.
No questions. So this approach of adding like whatever columns we need, so this is actually called as covering indexes. So till now we saw like clustered index, non-clustered index, and then clustered index with unique. There is one concept, and then finally the covering indexes. Okay. So covering index is nothing but like a non-clustered index where we can include whatever columns we wanted to have. Okay. So in this case, let's say, so this is my query. So what do you think like the execution plan will be? So I think it is better like people speak instead of voting.
Yeah, there's no option to unmute everybody.
Okay.
But I think people should speak. Otherwise, it's becoming very boring.
Yeah, so because I'm not getting like, so whether they actually get the point or yeah.
Yeah.
So
Agree.
I don't have any issues in continuing the same session for even 2-3 weeks also. Like that should be fine because like these are the basic things, and then so without actually understanding these things, like we cannot write better queries, obviously.
Agree. Yeah. And fine tune the
Existing.
database. Yeah.
Yeah. So actually there is a thin difference between like thin line of difference between like a good programmer and then good SQL developer and then SQL developer. So anyone they can write like whatever the basic queries like where conditions, and then so it is always better to know like so what is actually happening behind the scenes.
Mm-hmm.
So people usually think like this is the job of like a DBA, so index optimization or some of these things. Okay, so what execution plan do you think like it goes for? So obviously this goes for clustered index scan, right? So I think like scan, you can see like we are actually reading the number of rows, right? So it is almost like the complete database, 100,000, 10,000 likes. It is almost reading like 3 lakh records, complete database. Okay. So in this case, but in this case, okay, I should remove downloads. So here it is reading very less number of records when compared to those 3 lakh records, right? So how many of you agree with me that in clustered index, it's non-clustered index itself, let's include star. Like let's include all these column values. So today, actually, I thought of covering a different session. So basically, if you see, like out of 43 slides, okay. So I went up to only 4 slides, I believe. So all these slides they belong to like a different session altogether. Like, so if this is the case, like we'll again go up to 7 o'clock today also. Kiran, meek okay na Kiran, 7 వరకు? So how many of you actually agree with me to include like, so to include all these columns here, like, do you think like it is better to have all these columns here? Like,
No problem.
No.
no. So any reason?
Because if we do so, it will become a overhead. Like every time we insert or update, it should be re-indexing and checking with every single thing every time for each operation.
Exactly. So what's the main difference between a clustered index and then non-clustered index? So clustered index, it has data in the leaf level pages, right?
Yes.
And when you see like non-clustered index, so non-clustered index has only pointers, like they are actually they contain only ID value and then the non-clustered index value in the leaf level pages, right? So in some cases, when we do like this covering index, it will also the leaf level page of non-clustered index will have some of these columns, right? So if we include the entire table data, all column values, so there will not be any difference between non-clustered index and then clustered index, right? So both of them will have the data. And another drawback is the number of pages. Like if you see the page count, so sys indexes. So this is my. So I have like only 1735 records. This is for ID local. So ID local, this particular index has only 1735 pages, okay, including databases. This is all, right? So let's see like the primary key index and then other index. So do you think like primary key index will have more number of pages when compared to this index? So it has almost like 7403 records, primary key. 7403 records. 7403 pages. Next, the other index, user underscore display name. So do you think like this will have like more number of pages when compared to this index like IDX display local S? Which one will have more number of pages?
So primary key, first one has moved.
Yeah, obviously, like primary key will have like more number of pages. So out of these two, like user underscore display name and then IDX display local is.
So IDX display localage will have more pages.
It will have more number of rows, right? More number of pages. Okay.
Yeah.
Let's see. Yeah, obviously that should be the case. 1143. Okay. So you can see like if we go on adding like all those column values, so this index size will obviously grow, and then the number of pages like logical rates will also increase, right? So that's the reason why like it is not optimal to add all those column values into covering indexes. So another reason why we should avoid like select star most of the times is because let's say like in the where condition we have any indexes like non-clustered indexes, so they'll not be used. That's the reason why like we should avoid like, so most of the times we should avoid star, and then we should have like whatever columns we wanted to have.
What if it is all the columns?
So if it is all the columns, so then there is no question. So in that case, like we cannot do anything.
So then it is fine to have.
Yeah.
Like when you do in Dapper,
Yeah.
a lot of times you're getting the whole entity, right?
Exactly. So with Dapper, like we are actually getting the whole entity. So it will obviously go for scans. So that will be like, so even in Dapper, like we can ignore some of those columns, or like we can also pass like queries. So that's the reason why like many people, they don't go with like ORMs like an entity framework, or like, so why people they prefer Dapper is, so Dapper is just a next level to the regular ADO.NET. Okay, so it doesn't have those many fancy features like entity framework. So entity framework is somewhat costly because like so it makes the life of developer easy, like .NET developer easy, but not the life of like SQL server.
Right.
Yeah. So even with Dapper, like we can pass like queries and then execute. We can do like execute async, like something like that. Just passing the queries. Okay. So these scenarios, like they come into picture in very critical cases. Let's say like we have like a mission critical applications. Okay, so and performance is very important. Okay, so at that time, like so these play a good role. Okay. So any questions till now?
Pawan, I have a small question. Like you explained us like covering indexes, right?
Yeah.
So based on your expertise, can you give you a live example, like a production example, when to use covering indexes, at what scenarios we might use these covering indexes in order to get better results? Like it's not an immediate answer. You can give in sections also.
Yeah, so yeah, I'll definitely try to give like an appropriate answer in the next session. So right now, like most of the times what we do is like, so we actually like do joins with multiple tables and then fetch the data to show in a paginated grid or somewhere like that, right? So
Yes.
in that scenario, like most of the times what we do is like we do select star, right? So most almost like, let's say like if the table has like 20 columns or 25 columns, so we'll not display all all that information in this particular pagination grid, right? So
yes,
usually what people do, they show like major things like, okay, ID and then first name, last name, if it is an employee list. Okay, so and then they'll show something like a more details button or something like that, and when they click on this particular more details button, at that time like we usually query this entire table. So in that case, if we see, so in the pagination grid we are displaying ID, first name, last name. Okay, and then I have like more details button. So this more details button is nothing but like so it looks like details slash this ID value. Okay. So if we go, so in this case, if we do select star, let's say like this particular employee table, it has almost like 50 columns or 20 columns. It has like 20 columns. But in the pagination grid, so we are supposed to show only these 3 columns. Okay. And this is in the dashboard. So people, they regularly click on refresh button to see like how many people joined or how many people do we have, or this is something like that. Okay. So more often like we call this particular query. So in this case, instead of doing like select star from employee and then getting all those 20 columns, okay. So so even though like I have some clustered index, so maybe like date, okay. Here I have like where date range between last week. So date range last week, okay. Okay, so even in this case, so I have, let's say like I have a clustered, non-clustered index on a date column, created on column. Okay, so in this case, we are still selecting with, we are going with star. So when we are actually going with star and we are doing like pagination, so pagination, it will always do like clustered index, it will always do scan, because pagination, what it does is like, so it will get all the records from the table and then it sends us like only specified amount of records, like, so that's with pagination. So in this case, it will actually go for a cluster index scan, right? And let's say like the table has almost like 1 lakh records or these many records. So even though like I have a non-clustered index on date column, but still it is not using that non-clustered index, right? So what I can do is like I can just create I query something like this, and then I can create date or something, okay, along with this, and then I can create a non-clustered index on date, and then include these columns, these 2 columns, okay. So if someone wants to see more details of that particular user, so what they can do is like they can click on this particular more details, and in this more details, anyhow, like we'll frame this ID, right? So when we have this ID column, so what query do we execute when we display more details? We'll display select star from employee where ID equal to this ID, right? So what does this do? Like, so this will obviously go for clustered index seek, right?
Yes.
So this way, like we are saying, saving tons of logical rates.
Okay.
Okay. So any other questions? Or is this example like clear, or did I confuse you guys? Okay, so we saw previous session questions. We saw foreign key related question. Okay, so let me show you something. Read ahead rows. Okay. So till date, like when I'm actually talking about like logical rates, so we are mainly focusing on this logical rate count only, right? Okay. So along with that, like we also saw like LOB logical rates. If you remember, like Kiran, you asked me like why do we have like logical LOB logical rates? Yeah. So that is because like if we are querying like, so along on users column, if we are querying like any varchar of max columns, and if they are present in LOB pages, so at that time like we'll get. So that is another example. So basically like usually let's say like people, they wanted to do like select star, okay. So there are like few nvarchar columns which holds like a biography of that particular employee. Okay, so we anyhow like will not show that particular info, all his biography in the page, right? Data grid. So if we do like only selected columns, so these logical LOB logical grids, they'll be saved.
Right.
Okay, so now let's see like what this read ahead statistics. Okay, So we saw logical reads and then physical reads we'll see, and then read ahead reads. Okay. So now let's see what read ahead reads are. So so these many pages are available in my post table. So if you remember, like last time we saw, let me execute this. So this is my post table, and in my post table, like I have these many pages, 865691. So these many pages I have. Okay. I just want to show you something. So you can see like my SQL server, it is almost consuming like 7 GB of memory. If you see that. Okay. So what, before actually demoing these things, I'll do one thing. I have like few options to freeze, free this memory. Okay. So let me, yeah, I'll just show that in later sessions. Okay. So before that, like, let me, so what do you think? Like, so this 7 GB of, so this 7 GB consists of, so this is almost like 7 GB, right? So what do you think, like the 7 GB, what information is actually present in this 7 GB? Guess.
Yeah, logical pages, cache, like SQL
Mm,
internal cache.
no, okay. Others? Guess, like, కిరణ్ మీరు గెస్ట్ చేయండి కిరణ్, ఇంకెవరు గెస్ట్ చేయట్లేదు కదా అలా. హలో హలో
వినబడుతున్నాను.
వినిపిస్తుందా? ఓకే. Okay, so my SQL server is almost like consuming 7 GB of RAM right now. So if you see this particular from here, like I'm just getting only 224 MB, but this is not the right statistics. Okay. So here, like in the perf one, you can actually see what percentage of RAM is consumed by SQL server. Okay. So my SQL server is consuming almost like 7 GB. So let me try to restart my SQL server instance. Okay. So I did restart my SQL server instance. So you can see there is a drastic drop in this memory. Okay. So now you can see my SQL server. Where is that? Like SQL. So SQL server now it is consuming very less amount of data. So 555,668 divided by 1. So this is in MBs. So it is consuming only 54 MB of space. Okay. So after restarting, so I have like almost 6 lakh pages in memory, right? So what's the approximate size? So I was actually mentioning, right? So this is almost equivalent to later into 8. So these are pages, right? So I have like approximately this much amount of data. So let's do like a quick conversion, KB to GB. So this is almost equivalent to 6.9 GB. So all my pages. Okay. So let's see like how the memory is actually getting distributed. So till now, any questions?
People are listening.
Yeah, I think it is already 4, Kiran. So I think it is better to stop for today.
Okay.
Yeah.
Everybody following or no? We should give people a test.
Okay. 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 Again. So I think like it is already. I promised them like I'll take only 2 hour session. Okay. So
Okay.
let's have another session next week.
Yeah. Okay.
Yeah. Any questions? Like please ping me offline, or you can also ping me on Slack.
Sure.
Should we
Okay.
plan on having any specific queries that you were asking people to send queries that are slow in their particular application, so we can kind of analyze them, right? Do you want to do that now?
So maybe what they can do is like so they can start playing with like the Stack Overflow database, getting at least like so we have like good amount of data, so almost like 10 GB of data. So at least like we'll get an idea on what this clustered index can seeks because like these are the main
Let's do one
concepts.
thing,
Yeah.
right? Maybe next week, 3 or 4 people can present, do a small 10-minute talk, 5 to 10 minute talk about what they've learned and what they've practiced and show us. That would be better, I think.
Yeah.
Otherwise, if people are not learning or there is no point having these meetings, right? Waste of your time as well.
Okay. Yeah, so what they can actually do is like, so they can go through these videos or they can actually read some articles on internet and then, so if they have any
Yeah.
questions, like I'll be ready to answer.
Yeah, or they can present a topic that they've learned, maybe.
Yeah,
Something like that.
definitely.
Yeah. Okay. All right.
Yeah.
Let's do that.
Okay, Kiran.
Okay.
Yeah.
Thank you,
Thank you,
Pawan.
guys. Yeah. Thanks for your time.
Bye.
Yeah. Thank you, Pawan.
Yeah, thank you.